Modern technologies, such as smartphones and electric vehicles, rely heavily on rare earth elements, or REEs. As demand grows for these products, the United States faces a significant supply challenge. There simply aren't enough conventional sources of REEs to meet future demand. This is compounded by the fact that China dominates the production of REEs, accounting for more than 70% of what's produced globally. The United States is a distant second at just 14%. In addition, our nation imports 95 to 100% of the most important REEs needed to produce defense guidance systems, computer hard drives, solar panels and windmill turbines, and other essential technologies. To help overcome this challenge, researchers at the National Energy Technology Laboratory, or NETL, have developed and validated the world's first systematic, big data, and artificial intelligence-informed approach for the exploration and discovery of unconventional sources for critical minerals, or CMs, which include REEs. NETL's Unconventional Rare Earth Element and Critical Minerals Resource Assessment Tool, also known as the URC tool, was developed to reduce U.S. reliance on foreign REE and CM producers by systematically identifying new, unconventional domestic sources. To do this, NETL researchers established the underlying mechanisms for how and why unconventional critical minerals occur in nature. That's because geologic resources, like hydrocarbons or precious metals, do not occur at random. There's a specific series of events and geologic criteria needed for mineral resources to occur. As we establish the how and why, we can then develop systematic, geologic tools that incorporate this information, helping the URC tool to forecast the where. The URC tool's predictions are enhanced through the systematic use of artificial intelligence, or AI, methods, such as generative AI, to help find and acquire data needed in the tool, machine learning-based clustering analyses of key subsurface properties used in the URC approach, and the use of fuzzy logic to reduce uncertainty and support AI predictions of CM resource potential. The URC tool is especially important for the United States, where the geologic criteria required to host conventional CMs are less common, but where the potential for unconventional CM deposits is favorable. The URC tool entails geologic characterization and spatial volumetric predictions to provide stakeholders with a science-based forecast of resource potential. The key geologic components needed for REE accumulation can then be assessed per the model using a data science approach. Formally defining the relationships between the data sets and the process of sedimentary REE accumulation is vital to a successful assessment at the basin, site, or stratigraphic layer scales. The results from the URC tool are presented to the user as predictions of resource prospectivity. The tool also provides stakeholders with an evaluation of prediction confidence. Together, these outputs can be used by stakeholders to prioritize and highlight the most prospective locations. These results can be used to guide further field-based testing and validation of resource potential using more traditional mineral assaying techniques. A significant outcome in the development and validation of the URC tool has been the discovery of a world-class accumulation of REEs at the Brook Mine in northern Wyoming, which is operated by Ramaco Resources Incorporated. Initial findings determined that the Brook Mine deposit contains high concentrations of heavy and medium magnetic REEs for use in applications that include advanced military and electronic technologies, high-capacity batteries, semiconductors, and more. In 2023, Ramaco, which has worked with NETL researchers for several years, announced that the mine may contain the largest unconventional deposit of REEs discovered to date in the United States. NETL's URC method represents a paradigm shift in how to approach the exploration and evaluation of critical mineral resources. This tool has and will continue to improve our domestic supply of essential critical mineral resources. Having an ample, reliable supply of these minerals will be vital as we deploy new technologies for use in our daily lives and navigate the clean energy transition.